Today we are going to discuss about ring oscillator using Cadence GPDK90 nanometer technology. First we can design a ring oscillator using odd number of inverters. For an inverter there is one PMOS and one NMOS. For that first we need to select PMOS and NMOS from the GPDK90 nanometer technology library. So go to instance, select I for instance, browse, go to GPDK90, select PMOS 1 volt and change the finger width and total width of the PMOS from 120 nanometers to 2 micrometer. Place here and again go to instance, browse. We need an NMOS. The finger width and total width of NMOS is 1 micrometer. And join these two using one instance, browse, 1 volt. Take the VDD from the analog library, analog lib, search for VDD, connect this to this one and connect the substrate of PMOS to the VDD. And now for NMOS, take analog ground, to design a ring oscillator we need odd number of inverters, so I am taking 3 inverters. I'm just copying this one, drag this and press C to copy, and again I am copying this one also. Connect the output of the first inverter to the input of the second inverter and say output of the second inverter to the input of the third inverter. The output of the third inverter will comes as input of the first inverter. So I am taking the output port also. I'm just representing it as V out. I'm defining the DC voltage for the logic 1 power supply. So go to instance, search VDC and DC voltage as 1.8 and place here. Again go to instance, search VDD in analog library. Same as well, go to analog library and search for ground GND. I am giving capacitors to the output of the each inverter. Go to instance, browse and select search CAP. By default there is 1 picofarad. I am not changing any value, keeping the 1 picofarad as this, and ground to each capacitor. Just check and save. If there are any errors, the window will be displayed, but there are no errors. Go to launch, ADEL, analysis, choose select transient analysis. I am giving the stop time as 200 nanoseconds only. Press OK and go to simulation convergence aids initial condition and select here. You can select output of the any inverter. Now go to outputs to be plotted. Select on schematic. Selecting Vout. Now do the simulation. So this is the output of the ring oscillator. I keep the start time as 200 nanoseconds. You can give 1 micrometer or anything you want. Now this is the ring oscillator for fixed capacitance. For variable capacitance, there will be different frequencies and different waveforms. Let's see this. Close this window. Here, change the C capacitance to C variable. Just I am keeping C underscore VR. Now just check and save. There are no errors. Again go to launch, ADEL, analysis. This time I am giving as stop time 3 micrometer. Okay. Outputs. Now I'm going to simulation. Select OK. Go to outputs. Before going to outputs, here we get edit variables. Just select copy from the C variable. The value expression I am keeping it as 1 picofarad. Next, to be plotted, plot the output. Now go to results. Go to tools, parametric analysis, and here double tap and select C variable. The range is from 1 pico to I am giving as 100 pico, and total number of steps as 15. Just I am simulating here only. See run selected sweeps. Just dragging it. See there are multiple frequencies. There are multiple waveforms. This is with variable capacitance. So when the capacitance varies, the frequency also varies. Now we are going to design layout for the ring oscillator. Go to launch, layout Excel, create new automatic, keep the type and view as layout and press OK. Press F for fit. Go to connectivity, generate all from the source, use chaining option, keep the minimum separation as 0.12 and keep all the components in boundary, and draw the hypo pins from poly to metal 1 and press OK. Use shift F to see the source and drains in a transistor. Use S to stretch the boundaries. I'm increasing the boundary level again. The distance between two consecutive PMOS or NMOS must be greater than 2.5 micrometer. So I'm moving this PMOS set to and this NMOS set. I'm just using align. I'm keeping this as a reference and I vary this. Now go to window, assistance, navigator. Navigator will show the connections. First we need to create the substrate for every PMOS and NMOS. Polytype, detach. Select top tab for PMOS and bottom tab for NMOS. Now I am joining the substrates. I'm joining the substrates of NMOS also. Now first I'm starting the connections from VDD. For VDD we need to connect both these transistors to substrate and then substrate to the output port. Now completed the VDD connection and then we are going to connect the ground. Here we need to connect these two substrate. I have completed the ground connections also. Now Vout. For Vout we need to connect both of these. Press P for path. Enter. To connect these two we need poly. For net 7 we need to connect both of these and also these two. Press P to join both of these polys. And we need to connect these two also. So use metal 1, center. So we need to join both these two. If we join like this, we will get a error because poly overlaps on poly. Layout can be done in many ways. So I'm just taking the poly from here and taking on this side and get an via, and I will connect to the metal. Your wish you can do in any way. So first I'm selecting a via. I'm keeping via in this side. After that, selecting poly path. I've completed the net 7 connection and I'm going to connect net 12. For net 12 we need to connect both these and these two. So I'm taking path, metal path, and then we need to connect this both using poly layer. And we need to connect both of these. We can connect using an via. So I'm using and I'm placing here path, center, and select metal 1. Press P for path. Enter and take the path from here. I have completed network connection also. Now I need the last remaining connection is V out. For V out, we need to join this poly and this metal. We need to connect this poly and this metal. We can draw using many ways. Just I'm placing an wire here. We need to connect this wire to the metal. So I'm using metal pin. I'm using metal path to join. Viewed connection is also completed. Go to Assura and run DRC. There are no DRC errors.